Hi there. Today we're going to look a little bit at functions. So 1.3 focuses on just some different features of functions, some of which you know, some might be new for you. Okay, so first of all, let's look at what a nice textbooky definition of a function. It's a relation that assigns to each element in a set, so each element in the domain, exactly one element in the range. So in other words, if I have a 1 here in my domain, it is assigned 7 in the range. And it has to be exactly one element. So I can't go from 1 to 7 and also go from 1 to 6. Okay, it's assigned exactly one value. Okay, if you're looking at a table, basically what you're saying, you can't take 1 to go to 7 and then also take a 1 to a 6. So I shouldn't ever see my x's repeat here. If the x's repeat, then that's not going to end up being a function. All right, let's look at what it means on a graph. If I go over 4, let's say, I am assigned this one value right here for the y. If by chance I went over 4 and I got a different value for y, maybe down here or something, well, what would happen is that would not end up passing a vertical line test if I were to draw a line. So let me throw in, let's say you have this point, but also you got this point down here. Well, if I run a vertical line through my graph at that point, it actually hits in two places, assuming that this was a point of something. Maybe it went like that or something. Okay, if a vertical line will hit the function more than once, and this could be a vertical line anywhere, like over here it's not going to hit at all, but here it hits twice. And so if it hits twice, it's not going to be a function. So we call that the vertical line test. Okay, so not always do you have a graph or a table. Sometimes you'll have an equation and you're deciding whether this is going to end up being a function or not. Okay, so we're going to look at this a couple ways. Let's start with looking at it numerically. In other words, if I pick a number and I plug it in for x, I don't know, let's plug 1 in for x. Am I going to get more than one y value back? So I'd have a 1 squared plus 2y equals 5. Well, this is just 1, so I'll subtract 1 on both sides. 2y equals 4, divide by 2, I just get 2 back. So it's not like I'm getting multiple y values back. And I don't know how that would change other than this being a different number right here that I'd subtract to the other side. The process would be the same, and I think I could only get one y value back. Okay, if you think about it graphically, ideally you can look at this and tell me what that would equal. Now later in this chapter we'll talk more about that, and I really will expect you later on to know exactly what this is. But if I have a y and I have an x squared, now this is not put in a nice parabola formula or form, but it is definitely a parabola. And so if you think of a parabola, it would only hit once no matter where I draw a vertical line. So it would pass a vertical line test. So it makes sense that, yes, this one would be a function. All right, let's look at the second example here. Okay, so again, if you just plug a number in for x, is it possible to get more than one y value back? So let's plug 1 in for x and see what happens. Add the 1 to the other side. Square root both sides. Okay, now remember right here, when you square root both sides, what do you need to attach with it? You should be putting a plus or minus. So I get a y equals plus or minus 2. So I did get 2 y values back. Okay, that's a problem. That's what I don't want to have happen. So I would say no, this is not going to be a function. If you think about it graphically, and you may or may not remember this, but notice on this one that you have an x and a y squared. Okay, that's actually a sideways parabola. So if you had a sideways parabola, yeah, that would definitely not pass a vertical line test. So I'm going to say no, this would not be a function. So you can look at these different ways to try to determine if you're dealing with a function or not. Okay, so let's do some evaluating of functions, and that's really kind of the point of whether it's a function or not is to be able to evaluate it and recognize that, yes, I'm only going to get one answer back. And for instance, if you had a function that represents what your pay is going to be, you wouldn't want there to be any ambiguity on what you get back. When you plug in my 40 hours, what should I get paid? You'd want one answer back. There wants to be an agreement between you and your boss. This is going to be my pay. So there's times that we're concerned with getting an exact answer back when you plug in a number. All right, so let's look at what we've got on this one. We're going to evaluate the function. So I have f of x, here's the function, and it says find f of -3. So this is just nice what we call function notation. And what we're doing is we're taking and we're putting a -3 in instead of an x. So it just means plug a -3 in for x. So if I plug a -3 in for x, I'd have -3 squared minus 5. So that would be 9 minus 5, so I get 4. So f of -3 is equal to 4. All right, let's try one that's a little trickier. What if what I want to find isn't really just a number, but it's an expression? Okay, same deal. You're going to take x plus 1, and you're going to plug it in for x. So then what we end up with, I'm going to come down below so I have a little more space here. I'm going to take, actually I'm not, I'm going to come up here. So I'm going to take my x plus 1 and put it in for x. So it's going to be x squared plus 1, or I'm sorry, x plus 1 squared, and then minus 5. Okay, be really careful with this quantity squared. You do not distribute a squared. You can't distribute exponents when you have a plus sign. You have to write x plus 1 times x plus 1 and do FOIL. But we have talked about that shortcut, and I'm going to try to get you used to using it. Remember, you take the first term and square it. You multiply the two terms and then double it, so that'd be a 2x. And then you square the last term. And I still have my minus 5 there. So clean it up, combine like terms, and this is what I end up with for f of x plus 1. So since I'm not putting in strictly a number, I'm not getting back strictly a number. I should have some sort of expression come back on that one. Okay, let's try going the other way. You have a question like this on your assignment. It says find the value of x such that f of x is equal to 0. Well, so if I want f of x to equal 0, I'm going to take 0 and I'm going to plug it in right here for f of x. And then I'm supposed to find the value of x that would make this happen. So in other words, solve for x. So add the 5. Square root both sides. Don't forget your plus or minus. So x would equal plus or minus square root of 5. Okay, last thing I want to talk about today is piecewise functions. And you've maybe done a little bit with this, but probably not very much. Piecewise functions means that you're not using the entire function, you're just needing a piece of it. And in all reality, a lot of the functions in real life, you're not using the entire function, you're using just a part of it. So a couple things that we're going to do with piecewise functions. First thing I want you to be able to do is evaluate. So all that really means is plug in a value for x and see what you get back. Okay. The thing is this piecewise function is split up. I actually have two functions. I have this function that I'm going to use anytime that x is less than or equal to 1. But I'm going to use this function anytime x is greater than 1. Okay. So when I evaluate and I plug 0 in, I don't plug it into both. I have to pick the one that fulfills the restrictions here. So since 0 is less than or equal to 1, I'm going to use this top function. So then f of 0, if I plug it into the top function, I'd have 0 over 2 plus 1, which would be 0 plus 1, or just 1. Let's try 1. Okay, I have to figure out which restriction that covers, and so since it's a 1 and I have an or equal to here, that means use this function. So here I go. I'm going to plug to find f of 1. I'm going to plug 1 in for x, and so that's going to end up equaling 1 and 1/2. Okay, last one, 3. 3 is actually bigger than 1, so this time I'm going to be using the bottom function, and I won't use this one at all. So plug 3 in to the bottom function, and I get 3 times 3 plus 2. Well, that would be 9 plus 2, so that's 11. That's evaluating. Now, I did say, I don't know if you paid attention to this, it says just watch on this one, because I'm going to do another one, and if you just want to kind of watch what's going on, and then we'll kind of try the next one together. Okay, so the other thing that I want to be able to do, though, is to graph. And that's a little bit trickier. Okay, it helps if you can look at this and tell me what it is. Okay, ideally, you know what this function is. This is linear. It's nice slope-intercept form. This is also linear slope-intercept form. This is like a 1/2 x here. So I know that these are both lines, but they're just going to be pieces of lines. Okay, so a couple ways to do this. I'm going to kind of show you both ways. On the first one, if you recognize the function and are a pretty good grapher, your best bet's probably just to graph that thing and say, all right, so my y-intercept is 1, and my slope is rise 1, run 2, rise 1, run 2. Do that a few times, and here's your line. Except I don't really want that entire line. I only want that line when x is less than or equal to 1. So I go grab my eraser, and I get rid of all this when x is bigger than 1. And so it's like right to there-ish. And so this is the graph I want. And it stops at the edge here. Okay, then I could come back and do the second function. Its y-intercept is 2. Its y-intercept is 2, and I'm going to rise 3, run 1, rise 3, run 1. Do that a few times, and I can draw that line, but that was a bad line, sorry. But I'm really only interested in that when x is greater than 1. So I'm going to get rid of all this stuff where x is less than 1. Actually, I'm going to redraw that because I didn't like it. Sorry. Okay, so when it was 1, it was right here. And then I was up 3 over 1. So it's really just that part. So you get two pieces, two linear pieces. Okay, this won't always be that easy where you know exactly what these are. So in this next example, I'll show you kind of another way you can do that if you're not very good at recognizing, oh, that's a line, it's a slope-intercept form, blah, 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 blah. Okay, let's try one more. Okay, so let's practice evaluating real quick first. So we've got 3 different functions on this one. So it says f of x. Actually, let me just go ahead and I'm going to call it f of 0. So you're going to plug 0 in. When I look at my 3 options, I want this one because 0 is less than 2. So I'm going to plug 0 in for x squared. So 0 squared plus 3 would equal 3. F of 3. I've got to find the function that matches. F of 3 would fall in right here because 3 is between 2 and 4. So with this function, this is kind of weird. It says f of x is equal to 7. So no matter what x equals, as long as it's in this range, your y is 7. So I guess this is going to equal 7. Last one, f of 5. That's going to fall into this last category where x is greater than 4. So I'm going to plug in my 5 right here. So I'll have 2 times 5 minus 1. That's 10 minus 1, so that's 9. All right, now let's work on the graphing. Now, I threw some different types of problems. This one's nice. It's nice linear slope-intercept form. This one's weird because it's just a 7. This one is a quadratic because it has an x squared. All right, if you're iffy on your graphing, then what you want to do is just use these and kind of set up a table. I don't know that I'm going to set up the table, but I'm going to plot the points from it. So here we have x is less than 2. So let's start at 2 and start plugging in numbers that are less than that. So starting at 2, if I plug 2 in for x, I'd have 4 plus 3, that's 7. So I should have an ordered pair 2, 7 right here. And then I'm going to plug in a 1. So that'd be 1 squared plus 3. That's 4. So 1, 4 would be a point. Plug 0 in. You get 3. So 0, 3. Plug negative 1 in. Remember, it's supposed to be a parabola. I don't see a parabola yet, but let's get enough points we can get one. So negative 1 squared is 1 plus 3. Okay, now it's turning around. Plug in negative 2. So that'd be 4 plus 3. That's 7. Okay, see, I can see it turning around here now. All right, so there's my parabola. That would actually keep going. So the first piece is going to look like this. All right. Now, in all reality, I should have an open dot. I didn't talk about that on that last one. I should have. I'm sorry. But since this is not an or equal to, it really can't have a closed dot right there. I really should be putting like an open dot on that spot right there. So I can't make an open dot very easy. I'm sorry. But it should look something like that. Okay, on the next one, this one's an or equal to. So these would be closed dots on them. Now here's the deal. If I plug in 2, I'm supposed to get 7. So let's plot that point. 2, 7. Oh, I'm in luck. It actually fills that back in. But I'm going to change colors on this one. Okay, so now this is the second function. And it actually would fill that in because the two functions end up meeting. On that last example, they didn't meet, so they wouldn't have that. If I plug in 3, I get 7. If I plug in 4, I get 7. So it becomes just this little horizontal segment here is what I've got. All right, and it would be a closed dot on that last one because of the or equal to. And now we go to the next one, and I'm going to use 4, but it would be an open circle at 4 on this. So plug 4 in. You'd have 8 minus 1 is 7. All right, I'm going to go back to pink on this. So if I plug in 4, I get 7. Oh, it meets up again. So sometimes they meet up. So I wouldn't have to worry about the open circle business because the blue is already closed up right there at 7. Let's plug in 5. That would be 10 minus 1. So 5 up 9. Okay, let's plug in 6. That'd be 12 minus 1. That's 11. So I'm just off my graph there. All right, so I continue drawing it. Boom, got my graph. All right, so that's a little bit about functions. Good luck.